busy with trig equations, some will say solve for x. And if I say solve for x, it means it's a key sum and I want the general solution. If I don't give it in an interval, then it's not a specific solution. This is going to be a general solution. So this is not type 1, because type 1 was when you have sin, cos and tan. Focus. You have sin, cos and tan equal to a number. Now you don't have sin, cos and tan equal to a number. You have cos equal to sin. So this is type 2. And in type 2, we have either sin and cos on either side. Popped around, doesn't matter. But the type has the same angles. For the same angles you were taught a rule. Then you must divide by cos and it will become tan. That is what you must know of by heart. When you divide sin and cos, both of them by cos, you'll get to tan. But it has to be the same angles. What was the problem with that 3? Not much of a problem. Not much of a problem. What do you do with the 3? Times it by 3 and take to this side. Why don't you just leave it on the other side? Will it matter? If I just say this is a third, and I don't need to put in the step, but if I did put in the step, and I keep it there on that side, is it fine? Now I'm going to divide both sides by, which will make the sin over cos part equal to tan, but note, same angle. So sin of the same angle over cos of the same angle will become tan of that same angle. Somebody asked me, doesn't the angles cancel out? No. Sin of the same angle over cos of the same angle is tan of the same angle. Something that I failed to mention yesterday. When you were in algebra and you got to a sum like x squared plus x equal to 0, solve that for me, please. Can you divide by x? Please say no. And why not? Because you don't know if it can be 0. And if you do divide by it, you're going to lose one of your critical values, one of your answers. Because if you just divided it by x, it would have just been x plus 1. Gone is the 0. And yes, it can be 0, so you shouldn't be dividing by it. Now, let's come back to this technique. I'm telling you to go and divide by cos. Do you know what that value is? Oopsie, so I made a mistake. No, I didn't. Okay. Because cos is divided in, but it's not gone. Because cos is part of. Are you with me? Please keep this in mind. You never divide by a variable because you don't know if it might be 0. But if you divide sin by cos, it becomes tan, which means the cos is not gone. It's not gone. Division by the cos is then taken into account because it becomes tan. Are you with me? A little bit off the wagon there, but just to let you know if it might have worried you at some stage. You're not supposed to divide by a variable unless you know for a fact that it's not 0. Then you can. Alright, so if I got that, what's on the left-hand side now? The third. The kids that took the third and timed it to this side had 3 tan equal to 1. You in any case have to go to divide it by 3. Perfect. Both of them got to the same general solution or the same type 1. Tan is equal to a third. Now what's my technique? Type 1. First you get your, and your reference angle is?
18,43.
Right, correctly rounded off. 18,43, and then I've got to decide where my quadrants are. I know that tan, doesn't matter that it's on the right hand and not on the left, like always, right? Tan is positive in the
First quadrant.
first and third, and you know when you're busy with tan, you only have to do one of them because these two will always be exactly 180 apart, so you don't need to do quadrant 1 and quadrant 3. You don't need to. And the normal thing to do is most kids will then just go for quadrant 1. But if you really want to do only quadrant 3 and not quadrant 1, it's perfect. It's exactly the same answers if you go for specific solutions. Alright, So for quadrant 1, you just say, what's the wording I taught you? You write down the name of the angle, which is x plus 10, not x. X plus 10. Equal to, and in the first quadrant, it's just the 18,43, the reference angle, plus then k times 108. Am I finished? So x is equal to, take the 10 across, so it's going to be 8,43 plus k times. Wasn't I subtract the 10 here as well? Don't go crazy. It's unlike terms. Right, something k, numbers, the numbers go together. When I divide by something, if this was 2x, and you've got to divide it, then everything is divided by the 2. Okay. Now, something I want to mention to you, because you're going to start practicing hopefully in your exam aid book or any type of question paper you can get your hands on. Please just make sure you've got memos. Otherwise, how do you know that it's right? Okay? So once you look at the memo, sometimes it's going to happen. Exam aid. Look at the memo. You're going to say, ma'am, my answer's not the same as in the exam aid answer book. It might be, and this is a good example to show you. If they, for some sort of mystical reason, they said in the third quadrant it's 180 plus the 18,43 plus the K180, and they decided, ma'am, I don't want to do 1, I want to do 3. Then their answer would have been K times 180, if you work that out. Now, my answer, my memo that I got from Albert and I, that's the memo. Ma'am, my answer's not the same. Is it? It is. And how will you know that it's the same? Check specific solutions. Wait, ma'am, they never said I must do specific solutions. Then you choose for yourself. If x is, choose something logical, please. And not from minus 1,000 to plus 1,000, you're going to sit there forever. But if you just choose something like, for instance, negative 270 up to positive 270, not too small either, then you're not going to see what you want to see. If that was the specific solution interval, what would this answer then have been? It would have started specific solution with 8,43. Did you have to do specific solution here? No. Your sum was done and dusted there, except for that I lost a mark. Because I didn't write keys. Are you with me? Okay. But if you want to check your answer to Albert and I's memo and see if they are the same because you can't figure out why, then check the specific solution. This specific solution, you always start with k is 0, then it's just 8,43. Then if you add 180, you get 188,43. Do you agree? Yes. Add another 180. No, that'll be too big for my interval that I chose. Then go from 8,43 and subtract 180. How much is that, please? Okay, and can you subtract another 180? No, it's going to be 300 and something, so it's not going to work. So for my choice, for my answer, that was the specific solution. Then I go and I say, okay, let's take the memo and see what happens. If I also choose from there to there, the first answer will be 188. Plus 180, it's too big. Minus 180, you'll get there. Minus another 180, you'll get there. Then you have proven to yourself that your answer and their answer have the same specific solutions, making you feel, okay, I think my answer is right. Because there are different techniques as well. Most people use the ones that I teach you as well, but there are different techniques. And there are some different memos going around. You're going to sit there and think, I can't see why my answer is wrong, and I can't see why their answer is right and what they've done, because they've done something else. Then check their answer to a specific solution. And if that's not the same, then you must come ask me if you can't find your mistake, because then you have made a mistake. All right. So that's just a technique to check yourself. Are you always going to do this? No, please not. So you have to stop. There is your what solution? General solution. Unless I said, solve for x if x is between negative 270 and positive 270, depending on what I choose to ask you. That was type 2. So type 1 we all know is when you've got sin cos of tan equal to a number. Reference angle, choose your quadrants, write down your answers with keys. Now type 3, You already know what's going to happen here because you've got like a feeling. Yesterday I said to you this was cos and sin, but they had the same angle. Basically it comes down to there's only two terms. Sin and cos. Whether you put them together on one side, there's two terms, and you've got to switch them to the other side, it's still going to be two terms. Just two terms, and the one is sin and the one is cos. There the angles were the same. Then your rule is divide by cos so that it becomes a tan. So it's like a pattern, always going to happen. But now type 3 will also be just sin and cos, just two terms, but the angles are different. Then there's another rule. Then the rule says you make both cos because there's a technique behind it. I'll show you afterwards why this technique is like that. Most of you is just going to say, well, I'll just remember that that's the technique. Why, where it comes from, I'll show you later. So you're making them both cos. Now, how do I make sin into cos? Do you still remember that sin 10 was equal to cos? 80. Remember? From triangles, if the one is 10, the one is 80. This one's sin, opposite and adjacent. Hypotenuse will be that one cos, adjacent hypotenuse. Coming back to you. So then sin theta would be cos. Alright? That's the principle. How do you make them both cos? You use co-functions. Right, but it has to be cos. I'll explain in a bit. So the sin of a different angle than the cos's angle means I'm not by type 2. I can't divide by cos. I've got to make them both cos. So this sin will become cos.
70.
That's a theta. So that'll become 90 minus 2 theta. Are you with me, guys? And the cos here, please don't touch it. You're trying to make them both cos. Now, the next step is something similar to what you did when we said, what did we say the next step?
Take away the basis.
Take away the basis. What are you doing? You're making a logical deduction. Where's the 2 gone to? Logical deduction. Make a deduction. The cos falls away. Ooh, we don't want to say that loud. But you're making a logical deduction, which is not quite right. Because how many answers are you going to get from there? 1. There's supposed to be lots. K times 360 n and n n. Are you with me? Here comes the part that you either have to study or understand why it is, but you still have to do it the following way. You're going to put that angle in a bracket and you're going to put plus minus and k times 3, 16. If you've done that, you don't know why you did that at the moment, that's the way to do this. And you never ever in this type come back to reference angle and choosing a quadrant. This is a type all on its own. It's a weirdo type. It is a logical deduction where you write plus minus in front of the one angle and plus k3, 60. You're actually supposed to write plus minus on both sides. But remember in algebra when we also did something like x squared is 4 and I said, okay, well then square root both sides. What did you have to remember? To put the plus minus. But I also showed you, you should actually put it on both sides. But it's a waste of time. Because you're going to say plus minus x is equal to plus minus 4. How many answers are there? Not 4. The plus together with the plus, x is 4, and minus x is minus 4 is the same answer. Plus x equals minus 4 and minus x equals plus 4, same answer. That's why we know don't put it on either side. It's the same principle here. You can put them both with plus minus, but you're wasting your time. And if you really, really, really want to put the plus minus on that side and not on this side, it's still fine. Okay, but now, am I finished? Okay, give you an answer for theta for me. Please give me an answer for theta. I'm not finished. Where's theta? All over the place. I've got an equation with a plus minus. What did that mean in algebra? That basically you've got two sums. The one with the minus and the one with the plus. So 90 minus 2 theta equals to the plus, which makes no difference. Are you with me? Or the 90 minus 2 theta equals to the, what's that negative effect going to be? Both of them are going to be negative. And please, if you want to and you can, do that in the first step, do that. But then this is going to be 90 minus 2 theta. Alright, am I finished? No, long gone. I still have to get theta and theta. Are you with me? So how will I get theta here? Focus on what you're doing. Don't start taking theta there, theta here, wherever. The theta's got to come to one side because I'm trying to solve it. So you've got minus 2 theta minus theta equals 60 minus 90 plus K3, 60. And don't forget the K3, 60 is there from the start. Then we've got negative 3 theta equals negative 30, because I'm adding the like terms, right? Then we're dividing by 3, or negative 3, sorry, and the answer will be positive 10 and positive, okay, it's a 120. Because you've got to get that 360 there from the start. You don't just add it here on the end. So while developing, it changed into, that should have been a negative, I'm sorry. But let's talk about that. A child that writes a plus K 120 there, is he wrong? Not really. Because it means you're going to plus a lot of 120s and minus a lot of 120s. And if I write it as a plus, are you still going to plus a lot of 120s and minus a lot of 120s because K is negative 1 as well? So does it really matter? To us as mathematicians, we're feeling this child made a mistake. Divide by minus, divide by minus, divide by minus should be a minus, right? But in its essence, you're not wrong if you wrote plus. You're getting my argument there. Right. On the other side, we've got negative 2 theta plus theta equals negative 60, negative 90, plus K. This is pure algebra. Pure algebra. Which will give me negative theta equals negative 150 plus K 360. Divide the whole thing by a negative, so it's positive 150, negative K 360, same argument. If you put the plus there, you're not wrong actually. I know you made a math mistake, but you're not wrong actually. And write down, I'm finished. Hallelujah, I'm finished. That's it. But I never in this type ever got to do a reference angle, choose your quadrants, and then go on to the answers. It's always the same thing. So when the angles are not the same, you make them both cos, make a logical deduction. But then the blue stuff gets added in there, the plus minus and the K3, 60. Then you always have your two answers. Is it possible that this could have worked out to be, the thetas add up to 0? So you've got 0 equals 180 minus K360. We did that in algebra. What happens if the x just disappeared and you got something like 0 equals 4?
X is an element of
Then it's no solution. But if 0 equals 0, then it's an element of the real numbers. Can it happen here? Okay, all the algebra stuff can still happen here as well. You've got to be on the lookout for that as well. Now let me explain to you why we do what we do. Whether you want to know it or not, you're getting it now. Whether you remember it or not is another question. What it basically comes down to is if you take cos of an angle equal to cos of an angle. Because of angles being negative and positive, this cos angle could have been a positive or a negative. Because of cos being positive, whether it's a negative angle or not. So I'm looking at it like this. Whether my angle is a positive theta or a negative theta. I'm looking at this whole thing about plus and minus. Whether those angles are positive or negative, they will still be positive ratios. So that's why we take them back to cos. Because whether the angle is positive or negative, obviously with reduction formulas, getting them back to those quadrants, they will be equal to each other. That just depends on whether the angle was plus or minus. Then you'll still get to a positive ratio. This is why we write plus minus. And whether we're there and add 360 and add 360 and add 360, or there and add 360, 360, you're still going to get to all those dots and crosses that I explained to you in the first exercise. That's why we do it, because there are alternative solutions, which you don't touch, please, because this is the better one. So there's obviously a way of making them both sin, and then you don't have a clue what the rules are, and I'm not going to tell you either. When it gets to sin and cos, you make them both cos, because the rest of it, once you know it, is easy. You're always going to make the logical deduction. Don't forget about the plus, minus, and the K360. That's it. Then you just write 2 of them and do the algebra, and you're done. Because it looks like a huge sum, but it's actually just change the cos, do the deduction, logical deduction, plus, minus, K360, write the 2 answers, always. All right, let's get to your homework sum. So then to go and practice this, here's your homework sum. Definitely not type 1. The moment you start off, you should know this is not a left-hand side, right-hand side. This is not Pythagorean cast. This is a pair sum. Okay, ma'am, I've got 4. So you've got to have your ammunition ready. Now that if it's scarce, there's 4 of them. Tomorrow we'll do the last one. So if it's scarce, it's not type 1, this one. The moment that there are only 2 terms, and the one is sin and cos, then it's got to be type 2 and 3. Now, which one is type 2 and which one is type 3? I don't care. If in a week's time you swap around type 2 and type 3, who cares? You just have to know if the angles are the same, what do you do? If the angles are not the same, what do you do? You're getting my drift here. You're going to forget which one is 2 and which one is 3. Who cares? But when you see that the angles are not the same, there's a specific method. First of all, please you can take them both to either side. So there's actually nothing. I'm helping you here start off. Then you see, okay, well, it's sin and cos, and the angles are different. So the rule is you cannot divide by cos. If you divide by cos 2x, what's going to happen here? The angles are not the same to become tan. Can't do that. The method is you have to go to cos, and I just want to show you that. Because now here's a trick here. If it's 90, why can't I just change this one? So much easier. 90 minus 2x. You can't, because it can't go to sin, it must both go to cos. The method only works for cos on either side. There is a different technique for sin, and I'm not going to show you that. It's much worse than this. Alright, so 90 minus in brackets. Excellent. And if you don't want to put the brackets, it's fine. If you immediately tell me it's 90 minus minus, that's fine. And then we're going to go on with the rest of the sum. But are you with me? So this will be 90 minus x minus 30, which will become 60 minus x. Are you with me? A lot longer steps than that one. But then so be it. It's still going to be much more marks. You've got to just get to the answer. And then we go for plus minus, okay, plus k times 360. And don't forget to k is for a what solution? General solution. Because how many solutions are here? Don't say 2. Infinitely many. Alright. If I ask you, find me x, but it must be between minus 200 and plus 200, then it's a specific solution. You're going to do exactly the same thing. There's just going to be x is equal to whatever the answer specific of. Okay.